Hello students, in this video we'll build a confidence interval for testing if a coin is fair or not. Let's suppose we have a coin that flips to heads with probability p. Okay, and p is unknown to us. P is unknown. P is unknown. And we flip the coin a large number of times. Okay, let's find an estimate for p. Then estimate p as follows. Okay, here's what we'll do. We'll define Bernoulli random variables. Define x1, xn Bernoulli. P random variables. And what will happen? I'm going to get I'll define x to be x1 will be equal to 1 with probability p, and x1 will be equal to 0 with probability 1 minus p. Okay? All right, then how will I estimate p? I'm going to estimate p by p hat is going to be what? It's just going to be 1 over n. The sum, j goes from 1 to n of these xj, just the sample mean of those xj, okay? So then what's the expected value of p hat? The expected value of p hat is going to be 1 over n, and then there's n of these things, and each of them has expected value p, right? So the expected value of this estimator is p, right? Which shows this is an unbiased estimator, so this is unbiased. Okay? And what's the variance of this estimator? The variance of this estimator of p hat is going to be 1 over n squared, the variance of any one of them, which is going to be n times p 1 minus p by properties of Bernoulli random variables. And so the variance of this thing over here is just going to be p and then 1 minus p over n. And now the central limit theorem tells me that these random variables are approximately normally distributed, right? So these random variables, p hat is approximately normally distributed. So p hat is approximately normal, p and then square root, well, just the variance, right? So that's going to be a p 1 minus p over n, where that's now I'm using that for the variance over here, over there, okay? And so now what can we do? So now we can say that if I want to find a 95% confidence interval, I'm going to use this normal approximation. So the probability, we recall that the probability at negative 1.96 less than the standard normal less than 1.96 is equal to 0.95, which is 100 times 1 minus 0.05. In other words, in z over here is just a standard normal, 0, 1. And so what I can say therefore is I can say, oh, good, now we're in a good position, because I can now say that the probability that negative 1.96 less than what? Less than p hat minus p over the square root of, now I should estimate, of course, p hat now, so I can just put p hat over here. Less than 1.96 is equal to 0.95. And so therefore we have our confidence interval, right? Our confidence interval is going to be just p hat plus minus 1.96 times the square root of p hat 1 minus p hat over n is our 95% confidence interval. That's going to that over there. So we can write this also like this, p hat minus 1.96 square root of p hat 1 minus p hat over n, p hat plus 1.96 square root p hat 1 minus p hat over n. And there is our 95% confidence interval for the estimator for the p hat for the p, the probability the coin lands on heads. Thank you very much.